So as Tor said, I lead the Natural Language Understanding Research Lab at AI Sweden, and AI Sweden is our national center for applied AI in Sweden. And we exist in order to accelerate the use of AI in Sweden. Part of that is to accelerate the use of language technologies. The title of my talk is AI Meets Supercomputing from the Nordic perspective. That sounds like a very broad and general topic, and you will soon realize that this will not be as broad that I will be talking about. In fact, I will be talking about something much more narrow. And my interest is AI for language processing. If I would have been there like 5 years ago, I would probably need to explain what a large language model is. I think nowadays you all know, and you have probably all used large language models. But large language models are, of course, only a subset of AI. It happens to be the subset of AI that I like. So I'm going to, for the rest of this presentation, just talk about large language models and how we are doing in the Nordic region. So even if I think that you are all aware of these technologies, I think it makes sense to just make sure that we are on the same page when it comes to what these models are. So a large language model is simply just a statistical technique, often implemented in a neural network, that tries to learn language by simply reading text. And what these models learn is a probability distribution over language. And we can use that probability distribution either to sample from it in order to generate text, or we can use the probability distribution as a representation and feed it into some machine learning pipeline. And the way that we typically train these models is, nowadays we refer to it as a two-step process. So in the first step, we want the model to learn language, to learn the probability distribution. And that's a process called pre-training. That's where we just feed the neural network with large amounts of text. And we typically use some very simplistic learning objective, like just next token prediction. And by doing that on a very large scale, the model will learn the probability distribution over language. And that means that we can then enter a sequence into the model, and the model will continue that sequence. So that's a generative model. And that's very powerful, but it doesn't necessarily understand instructions when we have just pre-trained the model. So that's why we typically do a next step of post-processing, which is typically called fine-tuning or supervised fine-tuning. And that's where we feed the model with instructions and replies. So examples of how to actually follow instructions. And these are usually provided by manual examples. Human laborers have provided the data for that, or we can synthesize data. And by doing that, then the model will learn how to actually perform tasks in natural language. And then, of course, you might also do a third step, which is called alignment, where the idea is to teach the model how to behave. So don't say certain things and respond according to human preferences in this way. And that's usually done by some form of reinforcement learning. That's an optional step. For one, I'm not a fan of alignment. And if you're interested in debating that, we can do that during the coffee break. But the point of all of this then is that we arrive then at a model that has general purpose text processing abilities. So we can use a large language model that has been trained in this way to solve basically any type of text task. Another way of saying this is to say that these type of large language models is a first step towards AGI, or artificial general intelligence. Now, that's not an uncontroversial statement, but it is the first step towards general purpose AI systems. Okay, so that's about AI and large language models. A very short history of the development in Sweden, which will then transfer into what's going on in the Nordic region. So the modern large language models, or the modern era of language models, was sort of started in 2017, where Google published the transformer architecture for neural networks. In 2018, we started to see the first language models based on a transformer. which was the GPT and BERT style models. In Sweden, we were quite early adopters of the new type of language models. So already in 2019, we started a project called Language Models for Swedish Authorities, with the purpose of fostering the first iteration of development of Swedish language models, particularly BERT-style models at that time, and also to validate use cases in the public sector. And that actually led to some production-ready solutions in various government agencies that are, as far as I know, still in production, BERT-based classifiers mainly. But of course, in the middle of that project, during COVID, OpenAI published the GPT-3 paper. And it was clear for at least some of us already from the start that this was going to be something really disruptive and transformative. And that's the reason why we then formed the Natural Language Understanding Group at AI Sweden, with the only purpose of starting to build large language models in Sweden for Sweden. And that was an experiment to see how can we do that in a small country like Sweden, and especially at AI Sweden, where we don't have any resources. We don't have any compute infrastructure. We have a very small team of experts, limited funding. Let's see how it works. And it worked out pretty good by collaborating with other organizations, like RISE, for example, and other Swedish organizations. And already in 2022, we had already trained the first large language model, which actually is not a Nordic model, it's a Scandinavian model. So it speaks the North Germanic languages. So that's Icelandic, it's Danish, it's Norwegian, Swedish, and Faroese also. And we were very early, even internationally. It was the first large language model produced by a small language family and also produced from a national initiative like we did. Then we spent a year basically trying to get the model to be openly released. That was a long and tedious process, talking to lawyers all the time and sort of arguing for the benefit of open sharing of model weights. So last year the model became open. It's a slightly modified Apache 2 license. And this year we have been focusing particularly on producing much more high quality data for training the next iteration of models, looking at multimodality, and in particularly extending our scope now to work on the European landscape. And as Maurice said, we have a joint project called Trust LLM, which is about producing trustworthy, reliable models, particularly for the Germanic language family. We're also involved in a large project called Deploy AI, which is producing a AI on demand platform for Europe, and another initiative that I will be talking about towards the end here called EuroLingua GPT. Okay, so that's the picture from Sweden. So how are we doing in the Nordic region? Well, we're doing quite well, actually. And especially the Finns have been busy producing a lot of models. And I think that this is related to the resources available in the different countries. So in our case, when we trained our models, we had access to the Berzelius infrastructure in Linköping through a collaboration with an academic partner. And we were sort of the pilot test case on Berzelius to really scale up training there. It worked perfectly. It was a beautiful system. But of course, we sort of can't get access to that infrastructure by ourselves because we're not an academic organization. In Finland, of course, you have Lumi, and these models are all produced, I think, on Lumi. Most of them are being trained by the Turku NLP group, led by Sampo Pysalo. And the Viking and Poro models have been produced within a European project called HPLT, or High Performance Language Technologies, trained on Lumi. In Norway, and I think I might have forgotten one Norwegian initiative here because they sound so similar. So we have Nor LLM, which is produced in Trondheim, and then we have Nora LLM, which is produced in Oslo. It's very similar names. I think the Nora LLM is being trained on Sigma 2, and the Nor LLM is being trained on whatever system they have at Trondheim. But I think that the Norwegian models haven't been released openly, which is in contrast to the Finnish and Swedish models, which are open weight, and you can download them, you can modify them, retrain them, and use them commercially also in your whatever services you're building. Okay, so quite a nice picture in the Nordic region, but what about the Danes? Well, you do have an initiative here in Denmark, which is called the Danish Foundation Models Initiative. And as far as I'm aware, and there are people who know much more about that in the room, but things are sort of coming into place. You're working on data in one initiative, you're working on training models, I think on Lumi, pilot cases on Lumi. And I think there might be models coming out. You have challenges in Denmark, particularly when it comes to data processing. We also have that in Sweden, but my feeling is that you have a much more challenging environment here in Denmark. Okay, so this is the Nordic context. So how does this stack up to the European development then? Well, if we look at the European map here with the sort of large language models that have been trained in Europe, and please note that these are models that have been trained from scratch. This does not include models that are fine-tuned based on Llama or Mistral or something. These are trained from the beginning on a randomly initialized neural network. And I might have missed some models, but I think it's more a pretty complete picture at least. And if you look at which countries have actually produced these models, the Nordic region actually stacks up pretty well here. So the French people, they have, of course, produced a lot of models, and you have, of course, some French companies that are prominent in this respect. You have Mistral, which I think you all know about. There is also a company called Lighton, which have good competence in this era. They have produced the Lyra models and also the Falcon models, which are more international. From Germany, there is a big initiative called OpenGPT-X, which has been going on for quite a while, but I think that they are actually releasing models maybe even tomorrow, but soon enough. And then we have the Nordic models. So we are actually stacking up pretty well even in the European competition here. But on the other hand, so these are sort of available models, how are we doing quality-wise? So if we look at some of the benchmarks that are available, and this is how we measure quality of the models, we have these leaderboards where you measure the performance of a model in several different tasks, and then you average the result, and then you have a sort of leaderboard. So on the right here, you have the Hugging Face leaderboard for English performance, and on the left, there is the European leaderboard coming out of OpenGPT-X. So that measures performance on sort of a random selection of European languages. And if you look at where the European models are on these leaderboards, this is the picture. Not a very good picture. Even on the European leaderboards, the international models are outperforming our European models. And on top there, you have Llama, which is produced by Meta, and then you have a Chinese model. This is not good. We should be competitive on our own languages. Okay, but so keeping this picture in mind, you might ask, so what's the point? Why do we even try to be competitive here? Shouldn't we just use whatever Chinese model is available? And we think, no, we should try to build national models. And we have several arguments for that. One is that we need to build competence. This is a transformative, disruptive technology. It's going to affect everything we do in technology going forward. We need to have competence in this. We need to not only be users, but producers of these technologies. And that will spur innovation. That's where we will get startups and SMEs to actually leverage the power of this. Even more important, we don't know what the training data is in the internationally leading models. So if you look at Llama, they do not disclose any information about the training data. If you look at the Chinese models, there is no information about training data. So, and I mean, why should you care about that? Well, you should care about that because you need to know which parts of your population is not represented in your models, right? So it's trained on web data, and for those of you who write a lot of text online, you are represented there. But there's a huge amount of the populations in the Nordic region that doesn't write text on the internet, and they're not represented in these models. So when we do national initiatives, we can work actively to make sure that we have representativity and that we are transparent about that. And that's, of course, also enforced by our data protection regulation in Europe. We need to be transparent about what we use. And there is a horrible challenge right now when it comes to copyright, because if you look at web data, as everyone does, we take Common Crawl and we train our models. More than 90% of Common Crawl is copyrighted. So in European context, we can't use that data, period. How should we then proceed? I'll come back to that. Of course, it's a matter of resilience and sovereignty. If we pay AI tax to some country overseas and they decide to turn off all services, we're stuck. And I think a very important point here is democratization of these technologies. At the moment, we have a power concentration, and which will lead to cultural imperialism if we are not careful. We should counter that by having open democratic initiatives. And in fact, if you have written text on the internet, you have contributed to these models, but then you have to pay to use these models. It's weird. But okay, so these are all just sort of political, ideological arguments. This might be the only thing that counts. Existing models are not fluent on smaller languages, like Swedish, for example. And how do we know? Well, we can measure that using some benchmark. This is Skandeval from a Danish researcher called Dan, which collects a number of tasks in the Scandinavian languages, and then we can see the performance. This is the performance on Swedish on some randomly chosen open models like Mistral and the Llama from Meta. We can see that Mistral is a little bit worse than Llama on Swedish. But then what happens if we take these models and then we continue training them on high quality, large amounts of Swedish data? Well, they become better at Swedish. And that shows that these models are not fluent on the smaller languages. There is still room for improvement here. Now, Llama is the latest models from Meta, and you can see that the improvement gap is not that substantial anymore. And that will likely disappear over time as the hyperscale is trained on more and more data, and they get data from publishers, etc. But we do still have a gap to fill here. And I think that's quite important. And even if the sort of general capacities of these open models will become good enough, there will still be room for improvement in specific sectors like healthcare or security or law or something like that. Okay, speaking of open versus closed models, the picture on the left here shows the amount of open models being published over time, which is the blue line. And red is the amount of closed models being produced. And you can see that last year was really the year that open models became the dominating trend in large language models, spurred, of course, by developments from China and also from Meta, of all places. On the right here, you can see the performance gap between closed and open models. So on the top dotted line there is the sort of benchmark performance of closed models, and on the bottom here, the red dotted line is the performance of open models. And you can see that the gap is closing over time, right? Of course, this is one specific test, and it doesn't really show general capacity, but the trend is that open models are becoming so good that they will suffice for most practical use cases, at least going forward. So this is really interesting. But then when it comes to then developing our national initiatives, what is needed here? And there are basically four different aspects that we need. We need to have competence, we need to have funding, we need to have data, and what you guys like, infrastructure. We need that too. I'm just going to mention this, I'm not going to go into details here, but I think one thing that was interesting for us when we started working on this was we had good competence in our team when it comes to language models and deep learning. We had no experience or competence in HPC when we started out our journey. And this was something we had to learn, partly by trial and error on a HPC system, but also by having really good collaboration with HPC providers. In our case, we worked closely together with NVIDIA. And that was a really great experience. But we need to strengthen this sort of union of competences to be competitive. Of course, funding, this is something you all know about. These are large-scale projects. What I want to stress is that these are not research projects. In the Nordic region, we're very good at producing research funding and giving it to universities. But that's not going to make our region competitive when it comes to large language models. We need to build stuff. We need to produce artifacts. That's not a research problem. It's an engineering problem. It's not about reinventing new methods. It's about doing what we know works on scale. And that type of funding is simply not available right now. And we need that going forward. The artifacts should be the goal. And then we have the data thing. We need trillions of high-quality data. And as I said, in Europe, we need to be compliant with our data protection policies. And that is a challenging thing. We are working together with other initiatives in the Trust LLM project, for example, but also in the Nordic region. We have contacts with Danish foundation models and our Norwegian friends, our Finnish friends, our Swiss friends on how to handle these challenges in Europe. And it's a gray zone, to be honest. And then it comes to infrastructure, of course, and we have common interests, you and me. We want GPUs, a lot of them, with good interconnect. Very important, we also need large-scale allocations on these systems. I love EuroHPC. We use it all the time. We get access. It works beautifully, but the allocations are too small. We need large-scale allocations, and we need to be able to use systems continuously to train our models. So please tell your friends at the EuroHPC GO in Brussels that we need bigger allocations, extreme scale times 10 or something. Okay, this is a quite complicated picture, but I just want to show this is from Adi Fuchs. He's been doing a lot of nice pictures when it comes to compute costs lately. This simply shows that the training cost of leading models increase over time. So at the bottom here, you have the compute efficiency of hardware increasing a little bit over time, but the compute demands of leading models increases much more. So in effect, you have increasing cost over time. And this is the environment that we want to compete in when it comes to our European or Nordic initiatives. We just need more compute. Did any of you read this position paper in The Economist by Mark and Daniel? It's a call for open model development in Europe. I find myself in a weird position where I actually agree with these people. I think this was a very, very good paper. We should focus on open model development in Europe. That's the only way that we can compete in Europe. And in order to do that, we need all these things that I was talking about. We need compute, we need data, we need funding, and we need competence. And just one example then of what we are actually doing right now, and that's a weird design of the picture, but you can see what it says anyway. This is one initiative that we are working on right now called EuroLingua GPT, where the goal is to produce a set of open new foundation models for the European languages. We are starting out with the 24 official languages, but we are extending these to 45, 46 languages, dialects, code, etc. And it's a one-year allocation on Mare Nostrum 5. So we have now done the scaling work. We're now starting to train the models. So I guess the first iterations will come out during late fall, winter, and then during spring, the larger models. And it's a collaboration between AI Sweden and Fraunhofer IAIS. So there is actually no funding involved, it's just allocation. So we're just training models. And we have produced data from scratch based on Common Crawl, trying to do as careful filtering and processing as possible, but it is what it is. So last slide, I just want to push our models a bit. So if you do model development, you should publish your models openly. I firmly believe that that's the best way to go. We have all our models on Hugging Face. And if you actually look at this, some of them are GPT-3 models, which are our models trained from scratch. Nowadays, a little bit obsolete because they're like 2 years old. But we also do train some encoder-style models. We also do updates on the Llama models to specialize them for Swedish. We train some translation models, etc. But everything is open. So if you have needs for Swedish or Scandinavian LLMs, this is one of the places to find them. And I'm going to end there.